My name is Joy. I'm working for Google. I'm a software engineer. Currently, I'm one of the tech lead on the Istio Configure working group. So this talk is pretty much capture what we're having discussions going on in our working groups. And I'm very excited to be here and introduce you guys about Istio configurations. So I have a quick questions. How many of you have heard about Istio and know what Istio does? Okay, pretty much about everybody. So how many of you think like what really Istio's value is at? All right. So I will go through a few slides about Istio and what we think about what's the value Istio provides. So we're having a lot of buzzword about Istio and its features. Everybody know with policies, networking, APIs, security, metrics, a lot of features. What exactly those mean? In my opinion, the value of Istio is to turn workloads running anywhere, Kubernetes, non-Kubernetes, containerized, non-containerized into services. They can interconnect easily through configurations. So what exactly that means? So let me go to a little bit more detail. What Istio can do. Istio allows you to switch traffic through your prod and your canaries. Allow to switch your security protocols, MTLS or non-MTLS, or exposing a external service endpoints, or specify a API spec, or add the rate limiting, quotas, monitoring metrics, many of those, all without dev work. You can do all of this through configurations. That's the value Istio going to provide. You don't rewrite your service. You don't even need to redeploy your workloads. You install Istio and things works. So how that the magic happens? Let's looking at the architecture. So one key part of the magic is we're using Envoy proxy as the sidecar. The sidecar intercepts the traffics in and out through the workloads. And Istio introduced a whole right side. Let me use the projector. Right side, what we call the control plane services. Those are Istio control plane components to config the sidecars or talking to the sidecars at the runtime to enable a number of features, policies, routings, checks, all of this. So let's go a little bit deeper in this architecture. So those solid lines represent a possible runtime data flow. You can think of data plane traffics. Some of the Envoy proxies will be configured as ingress. Basically allows you to accepting traffic requests outside the mesh. And they do some routings and security terminations and all this. And gets the traffic inside of the mesh. Once the inside of the mesh, between the mesh traffic is, they're going to go through the sidecars. And the sidecars can be configured, also allow services, workloads to talk to services outside of the mesh. We call it the foreign services. We have three main Istio components that sits on the control plane. We're going to have more than that in future, but now we have three. So Pilot is the main configuration engine that supplies the configs to sidecars. That's how it pilots the combined information of user intent and the service discovery from the platforms, and tell the sidecars how to route the traffic and how to do load balancing policies and all of this. Through configurations API. And I will go through that a little bit detail later. Citadel is the security authority. Basically, it's a provision search for those services allows them to connecting securely. So you see, even those Istio components we call system services, they run beside the sidecar, so they can be controlled through security communications and the Istio policies as well. Mixer is the policy engine of Istio. So the sidecar at the runtime will send the checks and the reports to Mixer. And the Mixer has an adapter model that allows you to be able to extend those policy checks using your favorite infrastructure backends. They do CODAs. You can have your own CODA servers, or you have some CODA server running on the cloud. Mixer can help you to use that through adapters. So you see some of the services, like a Stackdriver is a Google Cloud service, and the Mixer has a Stackdriver adapter, allows you to send your metrics and the logs to Stackdriver, and your permissions and your only even your own infrastructure backends. So now we go to the configuration flow. This describes the current configuration architecture Istio has. Our configuration is built on Kubernetes extensible resource model called CRD. Until today, we only use the very basics of the CRDs. It's a pretty much configuration storage. And the components like a Mixer and pilots, they get configurations through the Watch API. And we having a Galle. Today we only having if it's on 1.9 clusters. We have the validation admission webhooks, and we have some configure resource of runtime validations. So basically, you can write those configs through kubectl or our istioctl wrapper, and write it into the APIs, and it will be stored in the API server and the etcd. So the Mixer and the pilot will watch the configuration change. The configuration changes will first go through the validation hooks if you are on the 1.9 clusters with those features on. Then Mixer and the pilot can get the new config updates. And the pilots pilots itself also receives also does the service discovery and the DNS resolutions, and gets to combine those the canonical service names that they found in the platform, combined with the user intent, and convert into configs for Envoy to be able to understand. And the pilot talks to Envoy, sends configs through the data plan XDS API. And that's what the current design and the architecture. This one gives you an overview of how many CRDs we have. We have a long list of CRD that's pretty much grow organically through the onset of Istio. So we have more features and more components. We're just having some more CRD types. So there's quite a lot of them. I will talk later is how we can address these CRD scalability issues. For those, but for now we're having some of this, and these are like quotas, and there's a metrics, and there's each adapters has its own config. Like this is a Prometheus, and the routings we have routing rules, and this is actually we have the new release will have changed its name. So we basically until today we just getting more and more configs as we scale with features. So if you want to know how to, because this talk, I will primarily focus on the concepts and design. If you want to know the practical part of how to write those configs, you can go to the website with our API. Is this a Power Audit? Looks like one of the, okay. Oh, now it's moved back. Thank you. You can go to the website, and we have the API spec, or talk to us offline, and we can help you, or attend one of the workshops so we can help walk through all those tasks we have on the website. So, so you see, with a lot of configs, we do have some problems we want to improve. So first, some problem is the authoring experience. You find that those configurations are very component-oriented. As I said, it's grow organically, and it carries a lot of implementation details of the components. So sometimes you find it's very difficult to figure out what configuration to write when they want to implement the features. You need to, it's not very obvious. You need to read the docs and to do a few trainings. Also, we only using the very basic features on Kubernetes CRDs. There's zero observability in terms of if you write a config that's incorrect. Once it gets through the basic validations, there's no way you know where it's go wrong. So we want to, maybe we can do better on that. And also some of the configs like metrics monitoring, we don't having a scope model. That allows you to do a sophisticated reuse across mesh services. And the echo model is not established through a lot of protections between the services in mind. So some of the changes may affecting all the services, and that's not desired. Config distributions also comes along. We always getting requests from users what we can do better than the basics Kubernetes will give us. Can we control the rollouts? Or if there's a better configuration, can we easily roll it back? And as I have said, the components gets all the configs, not much shardings. We have isolations we have done. If we can make it more efficient, then runtime can get less configs when we scale the mesh. And now the Kubernetes allows us to put in configs at the same time. Many config resources may change at the same time, and we don't have a good way to reasoning about what's being written and why something happens. It's very hard to backtrack. Multiple environments. We don't have automation to give us a way to configure them easily. So over the past few months, if you follow a little bit about what we talk in our working group, we have been thinking, what can we do to make this better? We're probably not going to address all these problems, but we want to see what we can come up that has a good value and make it a lot easier for Istio users to use. As I have said, configuration is very important for Istio. It's one of the very important user experience we want to improve. So I want to spend quite a bit of time about talking about what's next and our design proposal for what we want to improve and direction we are going. Architecture-wise, we see configuration is through a pipeline of various stages. The operators is the user part, and when the configurations goes through the components, goes through stages, in fact. We see when user write a config is through an input. That's how you provide your declarative intent. And those will be transformed if we think of if components effectively want some different representation of the intent than the users. We can having a separation and abstraction. So we think of, oh, maybe we have a transformation that we can have different layers of configurations exposed to different layers of the components. And then goes to sending those configuration into component, that's the distribution. And there's a stage called how the component consumes those configs. Some isolation of the consumption allows us to do some design some fancy features like A/B configurations or gradual rollouts in the future. And all of this, we want to have a pretty good story about the observability. So if config fails at any stage, we know where and when, and that helps debugging the system. And the first of this, we're gonna introduce new API layers. So all the CRDs you have seen in the previous slides, this will eventually emerge as the component configs goes to the components. And on top of this, we're gonna introduce the Istio API. That will pretty much only 3 types. One is the service config, consumer config, and then mesh config. I will go to detail what this is all about in the next slide. But in this slides, I want to say that we're going to having a new layer of API as a surface for the user. That we hope we can all user-oriented design. So make it easy to understand, and the features is well contained for per service experience. And these are Istio APIs, public APIs. And sometimes you can envision different use cases. May find the service config itself is not enough. We actually will allow to having a layer on top of config. We call it composable config. That's some investment that we can do to help to create some tools to compose Istio configs for some use cases. But composable config is not architecture to Istio. So it's kind of allows Istio to one of the scalability or extensibility of the Istio API. But on this service config, consumer config, mesh config, and component config are Istio architecture. So why we do that? The reason we're doing it is trying to turn component-centric configuration into feature-centric. That's how we see all the features gonna fit in those 3 APIs. So the mesh config. The mesh config, as we see, it will contain the small amount of global configuration singletons for the runtime, like a pilot address or mixer address, and how those Envoy proxy run. It's kind of like a flags. That's most of them like sits in the config map as in today, but we were eventually moving to CRDs. The service consumer config. I will go the service config. The service config we see is mainly what the users gonna write, because Istio is designed for service operators, and we see service operators as the main users, and that gonna configure the Istio features. So networking, routing, quota metrics, logging, securities, even service broker configs, and it's on IDLs. They are all service config. It's basically those configs to configure producer service, and that's how you think the mesh services should run. And there's a small set of configs that we call service consumer config. Basically, we try to provide a consumer overriding model for the service config. We don't expect there's many of them, but some of these are like a retries. Basically, this defines if a service consumer want to send traffic to Istio services and what kind of policy they're going to subject to. And some of the limiting can be override to the producer services. Now goes a little bit about the composable model. The composable models, as I talked, for some larger meshes, as you see from the previous slides, Istio config API is a per service. If a mesh with 1,000 services. And those services, for example, if they want to report pretty much the same metrics, you will expect there's redundant. We still not yet resolved that problem. So the composable model actually allows us to build on top of the API. What we think we can provide something like a config packagers and introduce a new composable configs that may help with the help to reuse some of the configs. If you write one service config, or if you have another southern service config and want to pretty much do the same thing, that packaging can help. Maybe you can having a hierarchical model, giving you some way to reuse the config you have. And this will also works on different use cases. Some cases, if the users, they want to have some complicated echo models on certain pieces of config that can only written by certain principles, they can build on top of this. So in our config working group, we plan to provide one solution, one opinionated way for people to use, but we encourage people will find developing their own composable configs if they find that it fits better for their use case. So that's completely optional. And the last very important is with the service configure interface, you can also see the configure packager as a part of the CI/CD system. You can connecting to a source control system to push your config source. Now goes to the architecture of the main configure processing engine. In the previous slides, I talked about we view configuration system as a pipeline. So Galle is gonna grow from one component that only does being a validation webhook mutation validation webhook add-ons into a full-blown configuration service for Istio. It will, instead of the components, has the Kubernetes watch API, Galle with the main component watching the configuration changes. And the configuration, as these are the API, the mesh config and service consumer config, it's the same. We still use behind the Kubernetes API, we are being a controller. They also watch APIs, and then the Galle will do all the transformations, consolidations, optimization. That's all part of the transformations. And Galle will send the component configs to components, the pilot, Citadel, Mixer, and also the future, the Istio broker. And also, we are designing a new distribution API through Galle that's more efficient. That's not going through CRD anymore. A little more detail about what Galle does and the design principles. So Galle is an in-cluster solution. So Galle configs Istio per cluster. And it's provided low latency config delivery. Galle may read, in the previous graph, it shows some topology information that may help sharding and downscoping configs. Basically, we can send less config to the components. Galle will also try to provide some visibility about through the pipeline and the configuration rollout status. And in the end, Galle itself will stay as a controller to the APIs. A little more notes about what we think, how to do the multi-cluster environment solutions. For the very basics, it's a manual process. As I mentioned, Galle is an in-cluster solution, so every cluster will have a Galle, and the user will just send config to those Galles independently. That's gonna work. And you can have layered solution with a config distribution tool that helps to configure multiple clusters, and we can leveraging that as well. We will also provide some of the suggestion tools, the same as the composable config packaging system. But the Istio user allows to use their favorite solution. that will still give you the automations we can do to configure multiple clusters. So before I'm taking questions, I will just quickly talk about where we are right now in the implementation. So the design has been sorted out. The high-level architecture design has been sorted out, and we are in the next level of detailed design of the service configs and Galle and the distribution APIs. So the Galle itself is we are on the Galle clip-stop 0. So basically, we are introducing Galle into Istio as a component. And the first step, we just do a separation of the external CRD and internal CRD. They are, in fact, the same type. Basically, just the resources sits in external and internal in a separations. And the first step, Galle just does a sync through external, Galle being the watch API to the CRD changes, and kind of reads the external CRDs and then generate almost exactly the same internal CRDs. You can think of no transformation is being done. The value of doing it is now Galle will be engaged in the configuration flow, and we can do incremental improvements on the APIs. And eventually, those external CRD will evolve into the new API we want to see. And this internal CRD will retire through the new distribution API. If you want to know more about our working group, please go to the links we have in working group contacts, and all the meetings are there in the YouTube. And we have in working group community meetings every week. Welcome to attend. If you want to know more about Istio, that's all the websites you can go. So I having like 5-10 minutes, I think. I can take plenty of questions. If you want to ask any questions, please go to one of the mic in the middle. All right, no questions?